All right, so the issue that we have is, you know, if you want to find the area of a square or a rectangle or a triangle, then yeah, there's some geometry formula out there. Plug in the numbers and then you can solve for what you need. But if you are strongly considering a career, maybe being an engineer, you don't want to build a car or build a bridge over just squares and rectangles and triangles. It's going to look like a third grader built it. So most of the stuff that we have has some curvature to it. Most real things do. So like if we had an equation that had, I don't know, some back and forth here. If we wanted to know how much area this is with this curvature, well, you can do that with calculus. In fact, you can find the exact amount of area. And that's what largely what integration does for us and what we spend most of second semester on. But even though we don't know the calculus behind that yet, we can still approximate this, because what we can do is we can set up some rectangles. So we could say, like, I'll estimate this piece by doing this rectangle, and then maybe drawing another rectangle, and then drawing another rectangle. So you can see if I took the area of all of these rectangles, like this one's a little bit short because it's not getting some, this one's a little bit short because it's not getting some, and then this one's a little bit too much, and this one's a little bit too much. But if I added the area of those four rectangles together, you see how that would be a decent approximation to the area under the curve? Mm-hmm. All right, so that's all left sum, right sum, and midpoint sums are trying to do. It's trying to set up a few rectangles. We'll find the area of the rectangles, add them together, and we get an estimate of what the area is. And even though this is an estimate, and later on we can give the exact amount, this is something that is tested on the AP test. They want you to be able to estimate these. Okay, so I think I put these pages in the opposite order, but I actually want to look at, we're going to practice. I'm going to do one set of these for you as practice and one set for you as guided practice. But let's go down here and look at these examples where it's been worked out. Okay, so they're taking the equation y equals 1 over x. So notice all down the left side, I think on the back page, they graphed part of that graph. And we're going to try to estimate how much area is between 1 and 6. So obviously, it's a different amount of area than it would be than 2 and 6 or 5 and 6. But between the x values of 1 and 6, let's say that we want to estimate that. And we're going to do it with 2 rectangles. Okay? So the more rectangles you do, the better. 1 rectangle is going to be pretty far off. 2 rectangles is a little bit better. If you did 100 rectangles, it's going to start to get pretty close because it would fit in there, but that would be kind of time consuming. So notice they've got 2 rectangles in here. Well, this is doing, I meant to be up here. Yeah, okay. All right, so this is the left, what's called the left sum. So if we want 2 rectangles and we're going from 1 to 6, you need to divide that into equal parts. So it's not like one rectangle gets to be width 1 and then the next rectangle gets to be width 5. They're always going to be at equal pieces unless you're told how to deal with that. So between 1 and 6, that would be 1 and 3.5, and then 3.5 to 6. So you can see how they did that there. Now on a left sum, so again, the arithmetic's not going to be very hard because it's just area of rectangles and we add up a few of them. But you have to know the difference between a left sum, a right sum, and a midpoint. On a left sum, we focus on the left side. So you take this y value and draw it to the right, and then you get the start of the next rectangle. You start at the left point and you draw it to the right. So left sum, you take the far left x value of the rectangle. Okay, let's look at their example of a little more interesting problem. this would be left sum of this. They divided this up into 4 rectangles, and notice for the first rectangle, they started at the left point, went to the right. Second rectangle started at the left point, go to the right. Third rectangle from the left and to the right. And the fourth rectangle starts at the left point and then goes towards the right. So that's what we always do with the left sum. All right, well then once you've got that, later on we'll talk about what this fancy notation looks like. But think about, I mean, area of a rectangle is just length times width. So the width is 2.5. This is 2.5 and that's 2.5. They're equal. And the height, or the width, whatever you want to call it, depends upon the x value. So this y value, this is the function for that x value. The function at that x value. So f of 1. All right, that would be the y value there. You okay with that? Okay, so that's why they're saying that's the width of that rectangle. And then here, that rectangle starting at the y value when x is 1 plus 2.5 would be 3.5. So that's the height of that rectangle, or width, whatever you want to call it. So length times width gives us some number, length times width gives us some number. So the area of those two rectangles, total them up, and you get a number. And so we can estimate that the area between 1 and 6 is 3.21. Now, just kind of eyeballing that, do you think 3.21 is too big of an area, too small of an area, or do you think it's perfect?
Too big.
Right, so just kind of eyeballing it, hopefully you can see it's too much here and too much here, right? Both of them are more. So the actual area is less than 3.21. Okay, let's go down. I don't like the order that they do these, but let's look at the right sum. So same equation, still 1/6, but now still 2 rectangles, but now we're going to do right sum. So now when you're looking at your left rectangle and your right rectangle, your y value is going to come from the right side, the right x value drawn to the left. And then your second one is from the right point drawn to the left. That's why it's called right sum. Okay, well, the width of each of these is still 2.5. Here's the width. The height of this would be the y value right here. So the y value when x is 3.5. Height or width, length, whatever, doesn't matter. So width times height there. And then this one, we've got the width already, and then this y value is determining its height. So this is the y value when x is 6. So you can see that's what they're using as their height. Okay, so when it says f of 6, how are they changing that to 1/6? How do they know that this is 1/6?
So we plug it into the equation.
Right, we got the equation, so you can just plug it in, right? So plugging in 6 into the equation gives you 1/6. Plugging in 3.5 into the equation gives you 2/7. And so then again, this over here is the area of a rectangle. This is the area of a rectangle. They told us to do 2 rectangles for this problem. The AP usually does like 3 to 4 to 5, just kind of depends on what information they give you. And you piece them together. Okay, does this look like an overestimate or an underestimate? Right, so from 1 to 6, hopefully you can see that there's a bunch of stuff that they're missing here, and there's a bunch of stuff that they're missing there. So with the left sum, we saw that 3 point something was probably too much, and with the right sum for this problem, we can see that 1.13 is probably too small. So we know it's somewhere between there as far as estimating goes. But again, these are only two rectangles. 2 rectangles is kind of boring. But let's look at their graphic so that we can visualize that again, since that's kind of the part that takes a little bit longer to stick. But if we were taking this function and we were trying to divide up this area under the curve from A to B, and it was a right sum, you would take the far right of the first rectangle and draw left, far right of the second rectangle before you go left, the right x value on the third rectangle left, and the right x value on the fourth rectangle drawn left. That determines the height, the right x value for each rectangle. Okay, and then finally, the last one that we're going to look at today is midpoint. Midpoint's usually more accurate than left or right, but it really just depends on the function too. By the way, when we said that left was an overestimate and right is an overestimate, it depends on the function. It's because this one's decreasing that that's true. So don't just like memorize that fact. Okay, so notice, I'm going to do this one a little bit faster, but it's still two rectangles, length times width plus length times width. It's still 1 to 6, same function. So the width of each of these rectangles is still 2.5. But now the height of the rectangle is from the middle. So between 1 and 3.5, in the middle of that would be 2.25. So the middle point determines the height of that rectangle. The y value when x is 2.25. And then for the second rectangle, its x values are 6 and 3.5. So its height is going to be determined by the y value that comes from the x in the middle. And in between 3.5 and 6 would be 4.75. So midpoint, take the point in the middle, determines the height of the rectangle. Left sum, left point, right sum, right point. Okay, and then add up the areas together. All right, so here's a midpoint for us to visualize. Again, 4 rectangles. Took the point in the middle to determine the height, the midpoint, the midpoint, the midpoint. Taking the point in the middle of each of those. Okay, so let's go up to the ones on the other page. And what I'm going to do is I'm going to do the harder side for you as an example. So like I'm going to do 4 as an example for left sum. And then I'm going to ask you to practice that with number 4 and help you correct yourself a little bit. Okay, so the one I'm doing for you as an example from scratch, so notice the work's not typed up for us here, wants us to determine the area from -8 to 2, and they want us to use 5 rectangles of equal width. Well, first thing to do is to think about, like, how big is each rectangle then? So this delta x is going to represent, you don't have to know this today, the width of the rectangles. So from -8 to 2, if I want to divide that into 5 parts, how big would each rectangle be? 2. So like if you look at some of the other work on the other page, it kind of shows you where that comes from. But it's almost like a formula. But why memorize a formula? You can just reason through it. I need 5 rectangles of width 2 for that length. All right, now it depends. Depends on if you're talking about left sum, right sum, or midpoint sum. But I can kind of chop up my rectangles down here. Here's 1, 2, 3, 4, 5, all of width 2. This fancy notation, we'll talk about more of that next semester, but it's just saying add up those areas. So I've got 5 rectangles, and adding those up is going to give me an estimate for the area under that curve. Okay, well all of them have a width of 2, times 2, times 2, times 2, times 2, times 2. That's easy. The height of each rectangle changes because it's based on the x value. Now if it's left sum, I need to take the left x value of each rectangle and where it hits the function. So that would be left, the left of this one where it hits the function, the left of this one where it hits the function, the left of this one where it hits the function, and the left of this one where it hits the function. So some are too small, some are too big, but that's kind of nice because it balances out and means it's going to be a decent estimate. Okay, now of course I could plug in these values by hand, and just for time's sake here, I'm going to let my calculator deal with some of this. Let me get it set up. Okay, so the height of this one is going to be the y value when x is at the far left, so -8. So you shouldn't just look at the graph and try to eyeball the y value. We've got the function. So if I plugged in -8 into this, this is where it's going to be a little faster with my calculator. Yours, I think you can do just fine without. That's 3. And it looks like it's 3, so that's good. This one is the y value when x is -6. Y value when x is -6. I just have the function saved in my calculator to make it a little bit faster. So that's 12. Looks like it's 12, so that's reasonable. Okay, what is this one going to come from?
-4.
The y value when x is -4, which is 11. Eyeball it to make sure that's reasonable. Okay, this would be the y value when x is -2. I'm just writing that out so that you can see where it's coming from. And that's 6. That's what the graph looks like. And finally, this one comes from the y value when x is 0. Plug in 0 and we would get what?
3.
0 plus 0 plus 3 is 3. Okay, so I had to understand what a left sum was. I had to carefully get the length of each rectangle, or the width or the height, whatever you want to call it. But they all had the same width of 2, so that was okay. So if I take this area plus this area plus this area plus this area plus this area, 5 rectangles total, we would get 70 square units. That would be the left sum approximation. Okay, so I want you to try that now on number 4. Yours is a little bit easier because it's just x squared, but it looks like you're supposed to do 3 rectangles from 1 to 4. Try to make the picture so you can see your 3 rectangles. Try to get length times width for the 3 and add them up, the whole thing. Try to come up with the final answer. Give you like a 2-minute head start, and then I'm going to do it on the board too. I don't want you to look at what I'm doing on the board. I just don't want you to have to wait for me to do it from scratch too. Alright, so here's what my picture looks like. 3 rectangles, equal width, between 1 and 4, means they all have a width of 1. Since it was left sum, you should find the height by using the left side, the left side, the left side. Wherever it hits the function on the left side determines the height of each of those rectangles. So this guy comes from, this is the y value when x is 1. I think you really should write it out like this, at least first step. This is the y value when x is 2. And this is the y value when x is 3. Okay, well if we've got the function, we don't just have to hope it looks right and hope that we're not slightly off. Plugging 1 into the function gives you 1, plugging 2 into the function gives you 4, and plugging 3 into the function gives us 9. So that means this has an area of 1. Now doesn't that make sense? It's 1 block, right? It's exactly 1 block, so of course that has an area of 1. This one has an area of 4, this one has an area of 9, so 1 plus 4 plus 9 would be 14 square units. If you were asked to approximate x squared from 1 to 4 with a left sum approximation, you would need to say 14 square units. Is that okay? Questions? Okay, then let's skip down to number 9, where I'll do another one for you, and this time it's going to be the right sum. So mine are all the same function. Yours will all be the same function. So I've already thought about this 1, 2, 3, 4, 5 rectangles. I like to make the 5 blanks to kind of help me stay organized. The width of each one is 2. The easy information to get, so I'm going to go ahead and throw it in there. Okay, now I did left sum last time, so I found the y values from taking the left x value of each rectangle. But now we're going to practice doing the right sum, so we're going to do from the right side. So from the right side of this rectangle, wherever it hits the function determines that. So this would be f of -6. This one's going to be f of -4, f of -2, f of 0, and f of 2. So we will eventually look at like some practice FRQs where they've asked these before. Now, if this was all part of a FRQ where I don't think they usually just ask just left or just right or just midpoint if it's an FRQ. I think they ask like at least 2 of the 3. We'll compare this work that I'm looking at with up here, because I've already done some of this. Like almost like all but one of these I think match up to down here. So 2 times, so I'm scrolling up in my calculator. F of -6 I had already figured out was 12, so times that by 2. F of -4 earlier I figured out that that was 11, times that by 2. F of -2 is still in my calculator, that was 6, times that by 2. Okay, f of 0, I may have just not typed in. Oh yeah, I didn't type it in because I could do it in my head. So that would be 3 times 2, and then f of 2 times the width is 8 times 2, so that's 16. So really that was the only unique one. I'd already done these in my calculator. So the area of this one, which looks like it's too much, plus 22, which looks like it's not quite enough, plus 12, not enough, plus 6, which also looks low, but then this 16 looks a little bit too much. So this one, you added up those 5 area of those rectangles, you'd come out to 80 square units. But it's the right side, the right x value for each rectangle that determines the height instead of the left side. Okay, so finish copying that down, and then I want you to try that for your x squared example in your 3 rectangles. Alright, so I have the first part drawn out that we could just carry over from the last part. But if this is one of your rectangles, if it's right sum, it's going to come from the right side. So the y value in x is 2. And this is going to come from the y value when x is 3. This one's going to come from the y value when x is 4. Okay, f of 2 would be 4. 4 times 1 is 4. F of 3 would be 9 times 1 is 9. And f of 4 is 16. I guess since you've got it in a nice little grid there, you could even just count the blocks. But so that ended up being 29.
Yeah.
What you got? So 29 square units. That would be the right sum approximation. So again, even though it's not a great approximation, and we will have more accurate tools later, you need to understand they will specifically ask you on the AP test for right sum approximations. So even though we'll have more accurate tools, they still want to see that you can do this. Okay, any questions y'all want to ask about 6 before? Yeah.
I was just going to wonder, could you add the right sum and the left sum and then divide it by 2 to find the exact area, or would that not work?
No, it just depends. It wouldn't be exact. I mean, sometimes it could be, but it would just be a coincidence.
Okay.
Yeah. I will show you how to find the exact on this one after the next example. It's really not as hard as you would think it would be. Okay, so last one is midpoint, and so now we're going to take the middle of each to determine the y values, and this one gets a little messier, but it's the same idea. We just have to be careful with that y value. So between -8 and 6, which is where my first rectangle is, in the middle of that, so that height is the y value when x is -5. And then this one, except -7. Like I said, be careful. This one, the middle x value is -5. So wherever it hits, the function determines the height of that rectangle. This is the y value in x is -3. The y value in x is -1. And the y value in x is +1. So we're just taking the one in the middle. Sometimes you have to mess with some kind of messy decimals there, but not really an issue if we have a calculator. And again, I have this stored in my calculator. I have the function stored in my calculator, so I can just change the x values pretty quickly. So this, I'm going to times it by 2, 18.25. The height of this one times 2 for its width is 24.75. My third one has a height of 8.625 times its width, gives me an area of 17.25. -1. Times 2 gives me an area of that. And then finally, 1 is 8.25. Well, okay, thanks. Joe, you check that. And that's 8.25. So the other ones, I guess you could have an argument where it's like, yeah, I could just count the blocks. It's always kind of easy to see. It's hitting nice whole numbers. Well, these aren't exactly doing that. F of -7 isn't a nice whole number. Okay, and then so I've got 5 areas, add them up, and that gives me my midpoint sum. Literally the only thing that's changing is how to determine the height of each of these rectangles. And that's what I get for that one. All right, you try that for number 7, please. Yes. Yes. Alright, so we can see the width is 1 still. Got to carry that information down. Still same x value, still same function, all that kind of stuff. Now if I try to take the point in the middle, this height comes from the y value when x is, what x value did you plug in here?
1.5.
Okay, in between 1 and 2. And this one's going to be in the middle of these, so 2.5. And this one's in the middle of those, so 3.5. So plugging this in's a little messier. 1.5 squared, like 9/4. 2.5 as a fraction is 5/2. Square that would be 25/4. 2, 3. And this as a fraction would be 7/2. Square that would be 49/4. Did y'all write it out this way?
Oh, yeah.
Okay. So 9/4 plus 25/4 plus 49/4. I don't know, some kind of force. 60, 74 plus 9, 63/4. I could be off on my arithmetic here. I'm doing a lot in my head. Y'all need to speak up if you're. $63/4. All right. Well, 63/4 comes out to be 15.75. No. Okay. So where are we different then? Well, first of all, this would be 83/4, which is 20.75. Okay. So I'd say the hardest part of these, you can see, like, you can get bogged down in arithmetic. Like, you know, adding force, I should be able to do that, but still easy to make a mistake there. Okay, so in your opinion, which one's going to be most accurate? All right, just looking at it, like a little too much, but a little bit not enough. A little bit too much, a little bit not enough. Midpoint's actually not too bad. And then next semester we'll do trapezoidals, where we do a trapezoid in each of these. So we'll have to make sure you can do the area of a trapezoid. But it's basically the same thing. You split up in equal parts, find the area of a bunch of trapezoids, you add them together, and then you get that estimate. Okay, so if you think this one's the closest, and we said this one was not enough and this one was too much, what do you think the actual area is? If you had to, you don't know for sure. If you just had to guess.
Probably not like 21.
All right, 21 is going to be correct. Good guess. So here's how we're going to do this exactly next semester. I know that this is going to, you don't have to know the rest of this. You do have to know this. But we will talk about something called integration. And so let's say we want to integrate from 1 to 4. It's like saying, let's look at those x values. And the function you looked at was x squared. And then we put this thing out here, dx, which represents, like, tells us what variable we're integrating with respect to. Well, integration is actually the opposite of taking a derivative. So this 4 and this 1 will go out there. So what could we take the derivative of to get x squared? So you guys have only had to go one direction. You've just been taking the derivative, taking the derivative, taking the derivative. But when we do integration, we have to go the other way. So if we were taking a derivative, we'd bring the power down and lower the power by 1, right? So what's the opposite of that?
The power up and increase it by 1. So just
Okay,
do that.
we could, okay, test that. Does taking the derivative of this give you that? Okay, so then that's how you would integrate that. And you'll get used to that because we do it for a whole semester. And then we just plug these values in. So one time we plug in 4. One time we plug in 1. And then we subtract them. And so this would be 4 times 4 times 4 divided by 3. 64 thirds. This would be 1/3. So 63 thirds. What is 63 thirds reduced to? 21. So through integration, we'll be able to get the exact like this. And so we have to undo some derivative rules. We'll be undoing the power rule all the time. You don't really have to undo the chain rule, or you don't have to undo like product rule or quotient rule or anything like that. We have a different process for that, so that we don't have to like memorize some formulas and such. But so this type of problem will be a big focus the next semester. You don't need to worry about that right now. But you can see it's really subtraction, opposite process of what we've been doing, but there is an exact process to it. So you need to be familiar with left sum, right sums, and midpoints. So if I was you, I would probably summarize by making yourself any little notes, write yourself a sentence or two, anything you struggled with, so that when you look back at this 3 weeks from now, 2 weeks from now, you can quickly kind of remind yourself about what wasn't super clear to you right away. Any other questions before we call it quits?